Yeah, so welcome to this session. We are very, very happy that Christian invited us here to Prague to share with you some of our research concerning educational robots. But I have to say before we begin that we work on educational robots in a fairly theoretical perspective also. We do empirical research on how these robots affect children and other adults as well. But we also have our theoretical backgrounds, and you'll hear some of that here. So it's not just about how these robots are doing as educational robots, but also what a robot actually is, and how we can perceive of robots as something that engage with human beings. And we don't build robots either. So we are not really the persons to ask about technical details and stuff like that. What we do is we work on a number of different aspects of this new robotic trend. And today you will have a number of lectures. First I will say a little about our empirical work on educational robots in schools. Then Oliver Tafter will say something on a much broader perspective on how robots are actually connected with a much larger movement in the both technical, human and social sciences towards what we could call transhumanism in a philosophical perspective. And then Jamie Wallace will talk about humans through making and how a particular view on robots can be that they are a material production and how that affects the outcome of what a robot is. And then we will have our colleagues Mark and Alexei that will talk about ELFI Robotics Education Program, and that will probably be more hands-on also on how you actually work with it in education. And did I miss something? Did I miss your talk? Marie Søndergaard will also talk about robots in a much broader perspective as imaginaries. And you just keep quiet. Then we have Kathleen Richardson from UK, and we just had a wonderful seminar in Copenhagen with Kathleen where we discussed the effective and attachment aspects of working with robots. And then Maria Virchikova that will talk about intelligent social robots. And then finally in the afternoon, for those of you who would like to engage a little with our Neu robot here and also participate in our current project of conceptualizations of robots and drawings, we will have a workshop here, I think in this room, from 3 to 5. So first I will say a little bit about the Danish and UK persons here. We work together in this program that is under Aarhus University but based in Copenhagen. And we work on very interdisciplinary research on different kinds of technologies that come into people's lives. And what we especially are concerned with is how these new kinds of technological machines go into human already established social relations and do make a difference. So we study what kind of differences are taking place when we get new tools like robots. And I'll just give you a little insight into our work on empirical studies of robots in schools in Denmark. Denmark is one of the countries that actually has a lot of robot experiments in school classes. They work with the Neu robot that we have here, but they also work with Lego Mindstorm and other types of robots. And one of the things we think is important is that children like you here, you will have to be prepared for a future with a lot more automated workplace beings that you have to work with. And are people actually preparing you in schools for that kind of future? That's one of the questions we ask. There's no doubt that work in the future will change for our children. Of course, work has always changed. But one of the things that will change is that a lot of the things that today are sort of automated work that human beings do and relate to other human beings in doing will be replaced by robot relations. Frey and Osborne, they have made a survey that came out in 2013 that showed that in the US, 47% of all jobs will be replaced that were present in 2010 will be more or less replaced by automatic and robotic phenomena during 2020. And they recently came up with a new survey and a new research report that showed that it is not so that these replacements of jobs will be in all areas. It will actually not affect so much the really creative areas, but it will affect the creative areas as well. So even if you think that you will be artists or you will be composers, robots will also be part of your work life there, only to a much larger extent in more automated work areas. We work from a number of theories. One of them is post-phenomenology, and here we work on what we call alternative relations. All human engagements can be seen as alternative relations. We relate to each other. But when we relate to robots, Don Eide, a colleague of mine, has argued we relate to not another human being, of course, but a quasi-otherness. That means we are willing to stretch ourselves to read life into other, more or less, machine-formed entities. But still, we have to adjust the way we behave, because we don't get the same kind of response from robots as we do from human beings. And humans have always imagined how we will be engaging with creatures we ourselves have created. All the way back to Pygmalion, another myth, humans have dreamed of this. And in the former century, a lot of new experiments came up that created fantasies of computing machines that were more or less human-like. But these machines turned from fantasies into real machines gradually. And today we have machines like now here. But that's not how most children see robots. A lot of children today know robots exist. They know the concept of robot. But when we ask them to draw, what do they think a robot is? A robot that's doing something. They draw pictures like this. They imagine robots to a large extent to be autonomous beings that are capable, for instance, of love. This has been argued by another colleague of mine, Mark Koppelberg, that this is because whatever entity we're talking about, even if they're experienced in movies, they are to a large extent real, both to children and to grown-ups. So when we see an R2-D2 in a movie, talking and engaging with human beings, we tend to believe that this is a real existence and that we can actually transfer what we know from this film, movie being into the physical material, actual now robot. And that has implications colored on these romantic relationships that we see in movies, or romantic in the sense that it could also be the very scary robots we see, but in any way that we address robots as entities that are capable of engaging with us just as humans. And in that process, new practices emerge, but also new expectations. And one of the things we of course see when we go out in schools and study how children work with robots is that a lot of children get surprised when they find out how little robots can actually do today, and how little they're actually able to engage with human beings immediately. How much programming and how much work you have to put into it to make it work. And a lot of children, as I said, in Denmark have now robots in schools, but the curriculum for working with robots is not very explicit. It's often just about building a robot. And the teachers are not very clear about why. Why do they want children to build robots? Why is that? And I have a suggestion for them. They want to build robots with children in order to affect their already formed cultural imaginaries, so they get a much more realistic view on robots. And that can actually be supported in our research project in Denmark, where we ask children to draw robots. We say only the sentence, draw a robot or robots that do something. One of the first things that comes out is that when we say the concept of the word robot, everyone, almost, not everyone, but really many, draw human-like features like these ones. They do not draw a spinning machine, for instance, or something else. So a robot in the already established imaginary of children is an entity capable of doing something like a human. But we do see a big difference between the children that have actually built robots and the children that only know robots from movies. A lot of the children that we asked to draw robots, they draw robots from inspiration, they draw from their own background. For instance, this guy is playing kendama. Do you know this game with a ball and, yeah? He's playing kendama, that's pretty big in Denmark. So his robot is playing kendama. It's an autonomous being that takes pleasure in exactly the same things as Marcus. But Eric, he's actually worked and seen real robots. He's also been with his father to a robot exhibition. And he knows that robots have to have degrees of freedom. They have to have different kinds of fueling and so on. So his way of conceptualizing and drawing a robot and also explaining it to us after they've made the drawings, we discuss it with them, and he's capable of saying a lot about these robots. We see basically two ways of approaching robots. The engineering sense, where you have a focus on robots with hardware, electricity, cords and so on. And I think a lot of the people here will recognize that. And then there's the robots as a cultural force, as the philosopher Borgman has put it. And as a cultural force, we're not really prepared for robots. We have all these ideas about how they go into our lives and everything and what they can do. But in the engineering sense, we have a much more realistic approach to it. And that means that the same robot, if we look at a robot like now, we will be capable of saying that people look at it in different ways. And that really has an influence on how we engage with the robots. One of the words we use here is multi-stability. So robots are multi-stable in the sense that they look the same, but they appear and emerge differently, and that's why our engagements with them differ. And that has something to do with our learning experiences, because the same robot can be looked upon, and the children try to engage with it in our research as if it is a live being. They try to get eye contact, and they get extremely disappointed if it's not really reacting to them. Whereas the children with a more engineering sense, they have a much more realistic approach to it and ask about how is it programmed and stuff like that. So learning experiences are really important in relation to these new technologies. But it also shows our research that the children with the more cultural force approach, they are really interested in making contact, and they try to stretch themselves really far to pretend or to imagine that they have a contact with this machine. Whereas the other children, they are not really thinking of robots as something you can look in the eye. So there is a process of learning that stabilizes what we know as a robot, and that is something that teachers working with robots in schools should take into account, and they should be aware that building robots is not just to build robots, but also to teach about how to engage with these machines that will form our future. It's not new. We have always, as human beings, learned to engage with the technologies that we wanted to work with. But the point is that now we can see that these machines are coming very close to our work life, and so we have to learn to deal with them in a much more complicated way. And it's very obvious that the children who actually have worked with the Mindstorm, for instance, they take that experience into their drawings with them and explain to us technical details about their drawings that differ a lot from the other alternative relations. So, with that, I will just end this introduction.